Hi, I'm Phil, and today we're going to look at the twin of the Mars rover Perseverance. And that twin is called Optimism, and it is on Earth and is used to test all the new software and hardware additions that could be put on a rover like Perseverance later. And I'm using the Sunfounder GalaxyRVR Mars rover kit. And I also have a Perseverance, which is intact in the original form. And I also have the Optimism. So let's have a look at overall before we look at the rovers. So what we're doing with the Mars Exploration Galaxy is that we're trying to replicate some of the real experiences of a Mars rover. It comes with a processor, and that's an Arduino Uno R3. It also has a first-person view camera, and it's controlled with an ESP32 microprocessor. It has obstacle avoidance. It can be powered by the sun, and you can use your iPad for remote control. I've used it in the garden, and it goes over small rocks because of its robust construction, and it uses the rocker bogie. So let's have a look to see what I'm doing at the moment. So the projects, I've already done the construction, the testing, gone through the tutorials at Sunfounder, and I'm now trying out an alternative processor. And the first one was the Cedino, which looks like this. So it's fully Arduino Uno compatible, and it gives access to Grove sockets. Now, most of these I can't use because they're in conflict with the Galaxy driver board, but I do have access to the I2C pins, and I'm using those to extend the functionality, particularly collecting more data, using sensors like an accelerometer and a gyro, and it's worked quite successfully doing all of that. Now, the other processor that I'm trying is an Arduino Uno R4, and it looks a bit like this, fairly brand new, was only released about 6 months ago. And while it's more expensive than the Arduino, perhaps 3 times the cost, it's a much more powerful processor. And if I put on the firmware that was supplied with the Galaxy VR, it doesn't work. And I've been exploring some of the reasons behind that. So if we look at all the libraries, the library that doesn't work is the soft servo library. But many of the other ones do. So the lights also use the soft servo, and the camera view. These are the ones. So I've tested those individually, and it's possible if we don't use servo control or pulse width modulation control, we can get all the motors to work. I haven't tested fully the IR sensor, but the ultrasonic sensor works, and the RGB library doesn't work. The servo for the camera, for the tilt control, it works. The camera view doesn't, and the internal Wi-Fi using the ESP32 doesn't work, and the battery test does work. Okay, so some of the other things I've been doing are to look at, let's see if we can get the software going. Yeah, here we are. I've looked at a daylight sensor, and I got that to successfully work. So the one that I've been using is the Arduino Uno R4, but I've also added a Grove shield, and that's where the digital light sensor goes on. So this is interesting because although you have a quick connect connector on the R4, it goes on to a different I2C bus. So that was good. The next one I want to show you is a real-time operating system. So what I wanted to do was to demonstrate the use of the free real-time operating system, doing some concurrent tasks, and we'll have a look at that shortly on the video. So I got it to compile, and it's executing. To show you what the code looks like, we might just jump into the Arduino. Here we go now. This is the file in the Arduino IDE, and what we're doing here is to turn on a test LED or onto the port A3, and it's only one of the tasks in the real-time operating system. I'm still learning to find out how to add more tasks to it. Let's look at some of the communication projects I've been working with. So we're using the Uno R4, and if I just open up the comms programs, well, first of all, have a look at the web server. It'll be in a MQTT in the next project. And finally, we'll have a look at UDP. So we look at the web server. The arrangement is that I've got on the left photo, right on the bottom layer, there's a Arduino Uno R4. And the middle layer is a Grove shield, and connected to the analog ports, port A0 and A1, are two potentiometers, as shown on the right here. So the idea is that we want to capture the potentiometer settings and send them off via a web server and pick that up on the Chrome browser. So the Chrome browser is connected to the Windows PC, and it's using the home Wi-Fi server. So we look at the actual, what it looks like, the configuration. We've got a Grove shield sitting on top of the Arduino Uno R4 and connected to the analog ports A0 and A1 are two rotary angle sensors. So if we look at some of the coding for that, this is the web server, and we might actually fire it up again. So what I'm going to do is recompile this, make sure we're connected. So we're connected to the R4, and we'll just load that up. So you can see that it's compiling at the moment. We might have a very quick look at the code, and it's uploading. Once it uploads, it's going to look for the, we'll go to the serial monitor. We've got a message now that it's now connected to web address 10.1.0.147. And if we look at the code, or we look at the, here we go, we're getting, now I'm going to adjust the potentiometer. So the first potentiometer is at the maximum, and we get a reading of 10 23. If I adjust that, you can see that input 0 on A0 is changing. So it's on the minimum value. And if I go to input 1, put it on maximum, it's on 123. Then I'll go in the other direction, and it should also be 0 as indicated. So we might have a very quick look at the code on that. Now go back to the Arduino IDE. So you can see what I'm doing here. I'm calling up the library, the Wi-Fi S3, and that's because it's going to use an ESP32 S3. And you can see that I'm calling up the server in the setup. I'm connecting to my Wi-Fi, and I set up the server. And in the loop, I just simply read all of the analog ports, and I then set up a small web server and send them out to the web server. So, and you can see that it's coming up at the moment. Our next project, we'll go back to our mind map. That's the web server. The next one is an MQTT. And the idea here is that we want to send messages. We're going to send a random number to our MQTT server. So if we actually look at the project, the idea is connect to my MQTT server and do some testing of it. This time I'll just have a quick look at the code here. And you see the code coming up. So once I connect to my Wi-Fi server, I then connect, you can see I'm setting up with the MQTT server. And after that, I'm going to send the message across. So we might go and compile that one and send it up. So we've got MQT. Here's the program at the moment. And what I'm going to do is compile it and send it to my computer. So it's compiling at the moment. It's not connected to the right computer, so we'll just connect it to COM44 and have another go. And while it's doing that, we might close down the other serial monitor. So it's now uploading the program to our R4. And what we'll do now is look at the serial monitor. Okay, so it's attempting to connect to the broker. And we're waiting on messages. Now we might have a quick look at MQTT Explorer. And so we can find that, and we'll bring that onto the screen. So what's happening down here, the Uno R4 is sending a random number called test to our MQTT server. And we can send a message back the other direction. So we've got a message here, and we might actually publish something. So we'll publish a number. Oh, we'll just say hello and publish that. We've got test, test. We didn't quite get the message across. Maybe that if we look for our message, anyway, we'll might move on. It's looking for user magpie. So I've actually set up the wrong topic there. So what I'll do is set it up with MAGPIIE. So we've got a topic now, user one magpie. Hello. So it's if you look at the output on the serial port, we've received that message. Okay, the final project is Wi-Fi UDP. And the objective here is to test the program and send it to a Windows PC. And to do that, we're going to use Node-RED. So our hardware will just be simply the Arduino Uno R4 and a Windows PC, which is Magpie, and Node-RED. So I might go across to our Arduino IDE. So here's the program at the moment. And what we're going to do is close down the monitor and we'll compile that and send it to our computer. So it's compiling at the moment. Might not be on the right port. It's now downloading to our R4. And we'll have a look at the serial monitor. It's now connected to our Wi-Fi, and it's allocated an address 10.1.0.147. And we'll go and have a look at what that looks like. So we're on Chrome. Reload. It's not starting the web server. Okay, that might do us for the time being. Okay, so back on our Arduino IDE, we've compiled and sent the UDP program to our R4. And to see the results, we have to go across to Node-RED. But you'll notice we've got the wrong address there. So the address, we pick it up as 10.1.0.147. We go back to and correct that. And that should be 147. And deploy that. And we'll test it. So we'll send it up here, and you'll notice we get a reply back on the Node-RED debug monitor. And if we go back to the serial port, we can see that we've got a message in, which is test 1, as originally intended. So our Windows PC is talking to R4 using UDP packets, and we're using Node-RED to send and receive those packets. Okay, so that's the 3 programs, communications programs on the Arduino Uno R4. Here is Optimism, the twin of the Mars rover Perseverance. And it's here that we do all the experiments, test out new software and hardware, and if it works, we will then transfer the new development to Perseverance. So let's have a look at the makeup. We've got a new arrangement here where we've replaced the Arduino Uno board that looks like this with a Arduino Uno R4. So the configuration is actually a little bit more complex. On the bottom we've got the Uno R4, and next we have a Grove shield for Arduino Uno, and on top we have the Galaxy driver board. And we'll turn that on. We're doing unit tests at the moment, but we'll just have a look at some of the other features of Optimism. Right on the front we have a moisture sensor on a sensor arm, which is a servo. We have a camera, and on the top, or on the side, we have two motors on the rocky bogie. And we have the middle board feeds I2C sensors, and here is one of them, which is an accelerometer and a gyro. So it's using the Grove sensors for that. And on the other side we have another Grove sensor, and that's also connected via a I2C port, and it's a earthquake detector or a vibration detector using the Omron D7S. And we can also add a little bit more. We've got microphone and a light that go into analog ports. So let's fire it up and see what happens. We'll just turn on the power to our driver board. And here you can see that the motor software is performing okay. And that's our first test using the Arduino R4 replacement.